Hi students, hope you all fine. So now we are going to discuss about one of the property related to correlation coefficient. So the property is derive the limits of correlation coefficient. That means what? The correlation coefficient lies between -1 to +1. We all know that. So we are going to derive this property. Okay. So for that we can also say that this is one of the theorem. Okay. So proof. We all know that correlation coefficient formula is the formula of correlation coefficient is R equals to covariance of x comma y by standard deviation of x into standard deviation of y. Okay, so this can be written as 1 by n summation xi minus x bar or else yi minus y bar. Okay, whole divided by square root of 1 by n summation xi minus x bar whole square into square root of 1 by n summation yi minus y bar whole square. Okay, so like this we can write covariance and standard deviation of x and standard deviation of y. And now what we have to do is, here if you observe 1 by n we are having, and here 1 by n 1 by n, we can write this in the form of 1 by n square. If we take this 1 by n square outside of the square root, we can write it as 1 by n. So 1 by n summation xi minus x bar into yi minus y bar divided by 1 by n square root of summation xi minus x bar whole square into square root of summation yi minus y bar whole square. Okay, so this both gets cancelled. Okay, now what is the remaining term? R equals to summation xi minus x bar into yi minus y bar. Okay, whole divided by square root of summation xi minus x bar whole square into square root of summation yi minus y bar whole square. Okay, so now what we have to do? Now squaring on both sides we have to do. Okay, squaring on both sides. Okay, so r square equals to summation xi minus x bar. Okay, so xi minus x bar into yi minus y bar whole square divided by square root of summation xi minus x bar whole square into this one we can take as what? Okay, whole square will give into square root of summation yi minus y bar square. Again we have to write what? Whole square. Okay, in both the cases we are having square root and square. That means this square root, this square get cancelled, again this square root, again this square gets cancelled. Okay, so the remaining term is r equals to summation xi minus x bar into yi minus y bar whole square Okay, and the remaining term is, we are having what here, the remaining term is summation xi minus x bar whole square into summation yi minus y bar whole square. Okay, so whole by summation xi minus x bar square into summation yi minus y bar square. Okay, so now what we have to do is, now let here r square, sorry, why, because we did squaring on both sides, no, here r square we are having. So let ai equals to, let xi minus x bar equals to ai comma summation, sorry, into yi minus y bar equals to bi. Okay, so now what we have to do is, we have to substitute these values in the above term, that is nothing but r square equals to summation ai bi whole square by, again here xi minus x bar is nothing but ai, summation ai square into summation bi square. Okay, so what we have to do is, here we know one theorem. If you remember in your first sem, you can learn this theorem, that is nothing but Cauchy-Schwarz inequality. Okay, Cauchy-Schwarz inequality. So from Cauchy-Schwarz inequality theorem, we know that summation ai bi whole square equals to whole square less than or equals to summation ai square into summation bi square, we can write. Okay, so now what I'm going to write is, in place of this I'm going to write this one. Okay, so r square equals to, r square less than or equals to, no, less than or equals to, we can write here, or else one step you can do, that is nothing but here cross multiplication you can do, after that you can substitute. So r square into summation ai square summation bi square equals to summation ai bi square, sorry, bi square. Okay, and next now I am going to substitute in this term, that is r square summation ai square bi square is nothing but what we can write in place of this, you can write this one, no, so in place of this you can substitute this one. So summation ai square summation bi square less than or equals to summation ai square summation bi square. So in here both the terms gets cancelled. Okay, so you can cancel both the terms. So now nothing but r square less than or equals to 1, isn't it? So now r less than or equals to plus or minus 1, isn't it? Yeah, so now we can say that, therefore minus 1 less than or equals to r less than or equals to plus 1, we can say. Okay, hence the theorem, hence the theorem. Okay, so hope you all understand this theorem. If you are having any doubt, please comment in the comment section, so that I can able to solve your doubt. Okay, so this is related to statistics students, semester 3, very important theorem. Okay, you can expect in the sem exam. Okay, hope you all understand, and don't forget to like, share and also subscribe. Okay, bye, take care.